Hey guys, welcome to our Tech Talk presentation on Krino. Krino is a web application for photographers. It provides users with a platform where they can go to upload their portfolios and to receive constructive and meaningful feedback on their work from other artists. The word Krino itself is Greek for judge, which highlights an important aspect of the platform that allows users to improve their craft.
My name is Zarrin and I was responsible for building the front end or the user interface.
I'm Amy and I worked on the back end of the application.
And my name is Smilte and I worked on front end and back end.
So our target audience for our website was photographers. We realized that there was no real way for photographers to post and get feedback on their work. So rather than go through the hassle of building their own portfolio websites, photographers needed a place where they could get immediate exposure and critique on their work. They also needed a platform with which they could connect with other photographers and expand their network.
Krino lets users upload their own photos. Unlike other platforms, we encourage users to provide information on the camera that was used to capture an image and also information on the software that might have been used to edit the image. These images show up under the user's profile on their portfolios and also show up on the Explore page. The Explore page is where artists are exposed to one another's work, and it's also where they're encouraged to leave constructive feedback on one another's work.
To understand how the website functions, we are going to watch a demonstration.
So this is an overview of our tech stack. For our front end and user interface, we used React. For our back end, we used the Django REST framework, as well as the Pusher Channels API for real-time comments. For our external cloud storage for our photos, we use Amazon Simple Storage Service or Amazon S3.
This diagram represents what happens when a user logs into our website. So in React, we created a form using Material UI text field components, which had validation embedded into them. And the information that the user enters is saved into a state with the handle change function. And right after a user clicks sign in button, the email and password values are sent from the state to the API for authentication.
The login action triggers the Django login viewset, which parses the database for an existing user. So when a user inputs their email and password and hits enter, the Django login viewset will go into the database and see whether that given email exists and is connected to a user. If it is connected to a user, then it'll check to see if the password matches the password in the database. And if it turns out that the email doesn't exist, then it stops the action right there and tells the user that they need to sign up. But if the email exists and the password doesn't exist, then it just informs the user that they need to input the valid password.
For the sign-up page, we have the same Material UI form, but in this case, some fields do not require input. We have different validations for email and password, and we have a placeholder text to help the user understand how the information should be provided. After clicking the Sign Up button, the user is redirected to the login page.
The sign-up action triggers the Django sign-up viewset. The Django sign-up viewset takes the information the user gave in the form and first compares the username and email to the existing database. This is to make sure that no two people have the same email and or username. And if after the comparison it turns out that an existing user does not exist with the same username and or password, the signup viewset we'll call the custom user model. By calling the custom user model, Django is creating an object using the information that is provided by the user. This object is then also saved to the database. In a nutshell, the model defines the structure of the stored data.
Here we have diagrammed how we went about handling user file uploads. So starting off, we had an initial state in our front end where we had to have a button to push to start the process. Next, we had a loading state where the images were being uploaded and processed. To process the image, we used several React functions. Firstly, we used the handle click function on the upload button to let the user initiate the process of uploading. We also had an event handler called handle change, which is called from clicking the upload button. We used the useRefReact hook to refer to the hidden file input. The upload button attaches an array of the files selected to event.target, and we can access the file through the first element of the array. To handle the file input, we used a function called handleFile, which was passed as props by the parent component called photoform. The function changes the component state so that it recognizes that a file has been uploaded. To create an image preview, we created a temporary local URL, which was then rendered to the DOM.
When a user uploads a photo, they trigger the uploaded image viewset, which then triggers the uploaded image serializer. This serializer calls the base64 image fields function. This function makes sure that the file that was submitted for the photo is readable. After that, the data is passed back into the uploaded image serializer. Here, any of the other information that might have been submitted alongside the photo, including the title, the location it was taken, and any software that might have been used to edit the photo, are all saved. This information is used to then trigger the uploaded image model. A model sort of serves as a template for what an object is supposed to look like in the database. So after an uploaded photo object is created, it gets saved in an Amazon S3 database.
To allow users to leave feedback, first we provide information about the photo itself, which requires us to fetch this information from Django RESTful API. Values such as photo URL, title, username, date, and location are passed as props to the photo header component, where all of it is displayed. With a simple form, users can type in their feedback, which is saved into a state with the update input function. And once the form is submitted, a post comment function sends information to the pusher API and initializes a vote property on that comment to keep track of the number of votes. To actually post this feedback, we needed to create a server.js file where we set up our node server, routing, and in-memory database for saving comments and votes. In the component.mount lifecycle hook, we used the pusher client library to latch onto the events emitted by the server so that we can update the application's state and display the latest comments instantly. Here we are listening for the new comment event on the comments channel. Once the event is triggered, our application is updated with the new comment. Also, by using vote function, we were able to easily increase or decrease the vote count that belongs to the comment.
For the API structure, we start off in the main directory. This directory contains the Docker file, the pip files, the YML files, the requirement files, and the manage.py file. The manage.py file is a convenient script that allows users to run administrative tasks that are related to Django. This folder also contains the apps folder, which is our main project folder. This is where we are storing the bulk of our API code. We have the urls.py file, which defines mapping. It's essentially what allows us to access everything that's in our file. We can do this because the urls.py file contains URL patterns. They specify how you can call different parts of the API code. And by doing so, you end up kind of connecting everything together. The apps folder also contains the settings file, which is basically where you do all of your configuration. We also have the photo review directory, but more specifically, the photo review is considered an app of the apps project. And this folder contains models.py. Models.py is where you specify what you want certain objects to look like in the database. The serializers file makes sure that the data that was given by the users is valid. It also defines how the data is returned to the user. In the photo review app, we also have the views.py file. Now, views are functions which take requests and return responses. They're used to do things like fetch objects, modify objects, and return anything that might need to be returned to the user pertaining to the uploaded or updated data. And here again, we have the urls.py file. But this simply connects all of the URLs that are in this specific directory. It doesn't connect them to anything that's in the larger or parent directory. The parent directory is connected to this photo review child directory through the urls.py file that's in its own directory.
So this is our UI structure. So all of this contains our JSON files, YAML, Yarn, and other build files. We also had our VS Code settings directory, which was basically our code editor configuration. Our public directory contains our favicon or our logo, manifest.json, as well as index.html. Our source folder contains all of our components and pages. And also we had a file called serviceworker.js, which basically just lets our app load faster on multiple production builds. Our app.js is basically where the app is built upon. It contains all of our routing, all of our pages. Our components directory under our source files is basically the individual building blocks that make up each page. For example, we had edit user, explore, home, review, upload photo. All of these directories I've listed have their own individual components that we then can integrate into making our pages. So for example, here we have our upload photo directory under components, and it basically has components like our nav bar, our photo form, as well as a file uploader component. Our pages is basically a directory for all of the pages that we could possibly have in our site. And this also creates our grounds for our routing in app.js. So for example, here we have an upload photo page, which is basically just made up all of the components like a nav bar and a photo upload form, just basically all of those components stitched together.
Here we have some snippets of API code. On the left, you see a few lines taken from the models.py file located in the photo review app. And on the right, you see a few lines taken from the views.py file located under the photo review app as well. You can see how in the models.py file, we are specifying what we want custom users to look like. We're saying that we want them to have a full name, a username, any email, and all that other stuff. We also want users to set a password, but we're not explicitly stating that we want them to do so because of the abstract user class we are inheriting from. The abstract user class comes standard with stuff like password and username and email. But here we chose to define our own full name, username, and email fields. And this is because we wanted to make sure that the username and email were unique so that no two users with the same username or email could exist, and because we wanted to place a limit on how long the user's input for these fields could be. And underneath that, we have the uploaded photo model. Now underneath this, we can see that we are specifying that we want the image that the user uploads to have a title. We need to make sure that the image itself is uploaded, and we're also asking for a username. Now this is just to associate an image that's uploaded with a username. It makes it easier to when you're doing the front end stuff, to filter through all the images and make sure that you're showing the right ones on a user's profile page. We also have the location that the image was taken and a photo ID. Now, this photo ID generates, using the UUID field, a random ID for each photo. And we have this because when we are commenting on photos, we link each comment to a photo based on the unique ID associated with that photo. So we associate a comment with a unique ID which is associated with an image. And using the created at, we are using a date time field to keep track of when a certain post was created so that we can show a little timestamp at the bottom of a post. And then moving on to the right side, we have the code from the views.py file. So first, this view set will take in the information that was submitted through the login page. It'll specifically look for the email and password. And then it'll look through the objects that were already created to make sure that the email exists and that if the email exists, the password also exists. If the email and password are in the database, then the user is able to log in. Otherwise, they're not able to log in.
On the left, we have a code snippet from a React component called Edit User Form. This was basically a form that users would use to update user information such as their email, full name, and location. An interesting React function that we have is called component did mount. This function is invoked immediately after a component is inserted into the tree. This is responsible for instantiating a network request whenever data needs to be loaded from some remote endpoint. In this case, we're using it to load user profile data. We also have a save function which is responsible for making sure the site actually updates the user's info and holds onto it. Both these functions uses the Axios library, which handles HTTP requests. Here we use the get method to get the unique user object. We also use catch for error handling. In our save function, we use patch to change the user's state. On the right, we have our code for the edit user page, which is made out of components we already built, such as the navbar and the edit user form.
Here's the breakdown of what our continuous integration and deployment pipeline looks like. So our API and UI source codes were stored and managed in GitHub. Code changes would trigger a build and deploy via Amazon Web Services code pipeline. For the API, Docker images were built with code build, and then they were deployed via code deploy to an Elastic Container Service cluster for high availability. For the UI, the production build of React was also made via code build, and it was deployed via code deploy to an S3 bucket set as a static web host. A CloudFront CDN was placed in front of S3 to allow SSL encryption and lower latency access for the UI across geographic regions. Some of the lessons we learned throughout this project are collaborating remotely, so we mainly used Slack and Zoom meetings for communication. We learned agile development as well as organizing and testing code. We did some pair coding, so we learned how to review our code with teammates, and we used Trello app for segmenting projects fairly.
As we only had a month to work on the project, we didn't really have the time to include all the functionality that we wanted. So here are some ideas of features that we could add to the site to improve the user's experience. Firstly, we would add functionality for users to make tags on their uploads. This would make it easier for users to search for the photos they want to see. It would also be a great way to filter through photos according to the user's preferences. In addition to that, we would also add a search functionality that would allow users to search by user, tags, location, and date uploaded. We would also include a more tailored Explore page so the user would discover photos according to the post they've searched for and interacted with. We also want to make a more convenient edit user page as well as a feature to extract EXIF data from photos that would give us specific information about digital photography files such as size and color components.
Here's our contact information, so feel free to reach out.
Thank you.